Good day, viewers. I am producing these videos to support teachers of mathematics in helping learners make sense of mathematical concepts and their associated procedures and processes. And today I want to look at factors and factorizing numbers in particular. And I'm going to use the Cuisenaire rods to help me with that and to help make sense of what's going on here. So, let's say I want to look at the factors of a number like 12. Well, then what I might say to the learners is, right, using your Cuisenaire rods, can you create for me some rectangles, ignoring the depth for the practical manipulative, of course, some rectangles that have no gaps and no overlaps that use rods that have a total value of 12, or maybe that have an area of 12 if we've studied area. And so we might get learners creating rectangles like this one. This has a value of 12, 10 and 2, assuming, of course, the white rod is 1, which we're going to assume for now. I might get something like this. That's a rectangle with 6 and 6 make 12. I might get something like this. 3 4s make 12. I might even start getting interesting rectangles like this. But what I'm going to draw my learners' attention to here is the fact that no matter how they create these rectangles, there are only actually 3 unique rectangles that they can create. They can create a 1 by 12 rectangle, they can create a 2 by 6 rectangle, or they can create a 3 by 4 rectangle. And so these are the factors of 12. And that's the conversation I'll be having with my learners. These are the factors of 12. The factors of 12 are the dimensions of the rectangles that you can create, which use a value of 12 or cover an area of 12 if we've studied area. And so the possible dimensions I can create are 1 and 12, 2 and 6, or 3 and 4. And the other thing I'm going to say to learners, because I know I want to set this up for later on, is that these rectangles show how 12 can be decomposed into the product of 2 factor pairs. So 12 can be decomposed into a product that is 1 times 12, or 2 times 6, or 3 times 4. And so these are the 3 ways that 12 can be decomposed into the product of 2 factor pairs. From there, I'm obviously going to look at some other numbers, and important numbers that we might look at here are numbers like 9, because if I'm building 9, then yes, I can just build a straight 1 by 9, but I could also build a 3 by 3, and I need learners to recognize 2 things about this. One, that a square is a valid form of rectangle for this activity, and that also that although this means that 9 can be decomposed into 1 times 9, or 3 times 3, as 2 decompositions into factor pairs, into the product of factor pairs, that actually this only leads to 3 unique factors, that the 3 unique factors for 9 are 1 and 9 and 3, because we have this repeated factor, and we can talk about the fact that because 9's a square number, if we've studied square numbers to this point, that's why we're getting this non-unique factor, and that's why square numbers will always have an odd number of factors. And obviously another type of number that I'm going to want to learners to look at is a number like 13, and begin to recognize that no matter how they build it, that is in effect the only rectangle they can build for 13. And of course, I'm laying the groundwork there for prime numbers. The only factors there are 1 and 13, and therefore the only decomposition for 13 is to decompose it into 1 and 13. Whilst I'm setting up for primes, the other number that I would want to pay particular attention to in this scenario is actually the number 1. Because what I want them to see about the number 1 is that in common with square numbers, its decomposition is a bit weird because it's only 1 times 1, and so therefore it's only going to have 1 unique factor. And so it doesn't really have in common with the primes this 2 unique factor, this length and width that are different. And of course there I'm laying the groundwork for seeing why 1 isn't a prime number, as we tend not to call it in the majority of cases, and it's because of the fact that the factors here, or the factor decomposition, the 2 factors aren't unique. There's only 1 unique factor, and that is 1. And so by exploring these different types of numbers, we can start to sort of get a lead into looking at primes and why primes aren't there, looking at squares and the properties of factors of squares, but also in general, linking the idea of factors and decomposition into product of factor pairs with these rectangles. And that's going to be important when we want to look at factors and factorization in other situations, including in prime factorization. And there'll be a video that comes out around prime factorization and how this model can be adapted for prime factorization, but also, of course, in algebraic factorization. We're going to use that model again for those things. So that's just a short video on looking at factors and decomposition into products of factor pairs. As always, I'd like to say a big thank you to mathsbot.com and its creator, Jonathan Hall, for creating this wonderful website which houses all these virtual manipulatives, but not only these virtual manipulatives, houses a wealth of other things. And if you've never been to mathsbot.com before, then I thoroughly recommend going and exploring all that it has to offer completely free of charge to help teachers of maths. And of course, if you are interested in using manipulatives and visuals to support teaching of maths and helping learners make sense of mathematical ideas, then I would also urge you to go and visit my website, visiblemaths.co.uk. And amongst the many things you will find on there, you will find a link to the publisher of my book, Visible Maths. The publisher is Crown House Publishing, and on the website there is a link there which you can get access to some sample pages, and if it seems like the sort of thing that you might be interested in or might help you with your practice, then you can of course place an order. I'll be making these videos throughout lockdown, so if there are particular ideas, concepts, mathematical concepts that you want me to explore using manipulatives, and you want to see how they might be modeled or used with learners to support making sense of that concept, then please do get in touch and I will do my best to produce something for you. Thank you very much for your kind attention today.